Understanding quadrilaterals. Angle sum property. We'll see how to find the angle sum in a quadrilateral using different methods. First method is to divide the quadrilateral into two triangles using a diagonal. Consider any quadrilateral ABCD and here join two non-adjacent vertices using a diagonal. AC is a set of non-adjacent vertices and then BD. In this quadrilateral, angle sum property means we have to find what is the sum of angle A plus angle B plus angle C plus angle D. Now let us divide this quadrilateral. On drawing the diagonal, we can see that the quadrilateral has got divided into two triangles. One is ABD and the other one is BCD. And the vertices wherever we have drawn this diagonal, the angle gets divided. Now marking these angles, we'll substitute these values for each an angle of the quadrilateral. Angle A remains as angle 1, it didn't get divided. Angle B got divided into two angles, that is angle 2 and angle 6. C is as it is as angle 5, no division here. Angle D got divided into angle 3 and angle 4. Now rearrange these angles. On rearranging these angles, we will get 1 plus 2 plus 3 plus 4 plus 5 plus 6 like this in order. Now if we check, the first three angles 1, 2, 3 are from the triangle ABD. And as per the angle sum property of triangle, we know that sum of angles in a triangle is equal to 180. So substituting that value. And 4, 5, 6 are angles from triangle BDC. Even here, if we apply the angle sum property, we can substitute this value with 180. Adding these two values will give 360. So we have started with the sum of angles in the quadrilateral ABCD and this is equal to 360. This is how we can derive the sum of angles in a quadrilateral. Now let us look into another way of proving this. For this we will take four congruent chordboards of a quadrilateral, which means all these quadrilaters should have same measurements on their sides and angles too. Consider the four quadrilaterals here. Now we will join these quadrilaterals in such a way that at the middle point we will get all the four angles. So if we take each and every quadrilateral, we have A, B, C, D as the angles. Now joining of these things will be in such a way that we'll get all these four angles at a point in the center of the figure. So for the first quadrilateral, we will join the second one now. And join has to be in such a way that similar sides have to coincide. So let us take BC side from the first quadrilateral. This has to coincide with BC of second one like this. But here we need different angles at the center. For the first quadrilateral we already have C. So we will flip the second quadrilateral and see that B and C angles of the both the quadrilaterals come side by side. Now joining the third one. So AB of second quadrilateral and third quadrilateral has to coincide. Now we already have B at the center. So this time A will come at the center. So we are just going to join this as it is. And the remaining fourth quadrilateral we have to join CD of the first quadrilateral and CD of the fourth one has to coincide. But at the center we need angle D. For that we will just flip this quadrilateral first and then we will join this to the figure. Now if we look into this, we have got all the four angles at the center. And we know that angle at any point in a plane surface is 360 degrees. Using that property, we can say that angle A plus B plus C plus D at the center is equal to 360. But these four angles are nothing but the angles of the individual quadrilateral we have taken. So hence we can prove that angle sum of a quadrilateral is 360. Now consider the third way of showing that angle sum property for quadrilaterals. For that, take any quadrilateral and internal point for that. Join that particular point to all four vertices. Now consider a quadrilateral and let O be a point at the middle. For this point, we have to join all the four vertices. This divides all the four angles, marking the angles. Even at the center, we have four different angles. At any point, we have 360 as angle, but now it has got divided into four different angles here. Now, consider the first triangle AOB. In this triangle, we have three different angles 1, 2 and x. For that, we can write the angle sum property equal to 180. Transpose angle x to the other side, which makes 1 plus 2 equal to 180 minus x. This would be the first equation. Now let us take the second triangle BOC. Even in BOC, if we apply the angle sum property and transpose the y value, we get a second equation. Similarly, take the third one COD. Again, applying the angle sum property and transposing, we'll get the third equation. Now the last triangle AOD. From this also, we have to apply the same angle sum property and transpose W. This gives the fourth equation. From these add all the four equations. We'll get all the 8 angles on one side, and the second side will have the 180 minus x, y, z and w angles added together. If we start solving the right hand side of this equation, we have 4 180s, so which makes 720 minus of x minus y minus z minus w. Take minus common and then we can just write it as sum of that x, y, z, w. So 720 minus of writing the sum of angles. Now if we see this x, y, z, w are angles at the point O, which we know that sum of angles at any point is 360. So we'll just substitute that value of 360 in place of this x, y, z and w. So minus 360 gives 360. Now we have to further simplify the left hand side of this particular equation. And if we see this, 2 and 3 sum up to angle B, 4 and 5 sum up to angle C, 6 and 7 sum up to angle D, and 1 and 8 sum up to angle A. So on adding these angles, we will get the right hand side is 360. Hence we can prove that angle sum on a quadrilateral is 360. So far we have seen for convex quadrilaterals. To find the angle sum for concave quadrilateral, consider any concave quadrilateral and here join two non-adjacent vertices. A and C are two non-adjacent vertices. If we join these using a diagonal, the quadrilateral gets divided into two triangles. So considering the first method we have used, even in this case of concave quadrilaterals, we can tell that the sum of angles is equal to 360 degrees.